Hello, everybody. So today we're going to be looking at solving in quadratic inequalities. Our process here is going to be to find the x-intercepts, and then we're going to create a number line for those x-intercepts. We're going to test the number in each of the intervals that we have, and then see which intervals make the inequality true. And then we'll write it as and then we'll write our answer out. All right. So we have two cases, right? We can have it factorable or non-factorable. We're going to start with factorable ones because those are a little bit easier. So if I have x squared plus x minus 6, that's x plus 3 times x minus 2 is greater than 0. What you're going to want to do is just like factor these real quick. So that means that my x-intercepts are at -3 and +2 by the zero product property. So if I have them on a line, right, -3, +2. Okay, so now what I'm going to do is I'm going to test a value in each of these little ranges from here to here, from -3 to 2, and then from 2 on to infinity. I'm going to test a number in each of those ranges and see which ones make the inequality true. So, for example, -4, right? So let's test it. -4 plus 3 is -1. -4 minus 2 is -6. If we multiply them, that gives me +6, which is greater than 0. So yes, it works over there. Now between -3 and 2, if I can use 0, I like to use it because it's easy. 3 times -2 would give me -6. That is not greater than 0. All right. And then greater than 2. So let's use 3. 3 plus 3 is 6. 3 minus 2 is 1. 6 is greater than 0. So that works there. So we have an or situation. It's true over here or over here. So therefore, and I could have known this because I have a great or symbol. So this tells me that my solution is x is less than -3 or x is greater than 2. All right, let's try this again. I'm going to factor this real quick. If you need a review on factoring, I have a video on that. So this will be 2x, x, 3, 1, negative, positive. All right, so that'll give me -1/2 and +3. Create my number line, -1/2, +3. So now I'm going to test a value in each interval. So to the left of -1/2, it doesn't have to be a whole number. It can be or it doesn't have to be a fraction. It doesn't have to be one away or anything. It can be any number. It could be a whole number. So I'm going to use -1. So -2 plus 1, -1 times -1 minus 3 is -4. 4 is not less than 0, so it does not work over here. All right, and then in the middle, let's test 0. So that would be 1 times -3, which is -3, which is less than or equal to 0. And then greater than 3, so let's use 4. That'd be 9 times 1 is 9, so it does not work over here either. This is an and because it's between this and this. So therefore, and we could have been able to tell because this is a less than problem. And therefore, our solution is -1/2 is less than or equal to x, and x is less than or equal to 3. When I have a negative leading coefficient, I like to divide it out. Remember, when you divide a negative number in an inequality, you just got to flip it. So we'll have 2x squared plus x minus 6 is greater than 0. So this is going to be an or problem. I already know that. And I'm going to factor it. So 2x, x, 2, 3 plus minus, so 3 halves, -2. All right. So a number to the left of -2 is going to be -3. So -3, -6, so -9 minus 3, then -3 plus 2, -1. So that would be +9, which is greater than 0. And then we'll have 0, so -3 times 2, so -6. It won't work in there. And then 3 halves, so I'll test 2. 2 times 2 is 4, minus 3 is 1. 2 plus 2 is 4, which is greater than 0. So x is less than -2, or x is greater than 3 halves. You might be noticing that it's always a check x check or x check. It's like it's either the middle or the two ends. That's because if you have like a parabola and this is the x-axis, either the middle is going to be above the x-axis, right? Like either this is above the x-axis or the tails are above the x-axis. It can't be both. Or I guess it could be both, but then you wouldn't have any x-intercepts. And we'll talk about that in a second. So you really only have to check like the middle. And then unless you have a special case, we'll talk about those in a second. So from here on out, we're just going to check the middle interval. 3x squared is less than or equal to 27x. We need an x-intercept, so we need it to be equal to 0. So 3x squared minus 27x is less than or equal to 0. I can take 3x out of both of these. That'll leave me x minus 9 is less than or equal to 0. Therefore, my x-intercepts are 0 and 9. So I just got to test something in that range. I'll go ahead and test 1. So I'll have 3 times 1 times 1 minus 9 is -8. So that'd be -24. And that is less than 0, so it works here. It will not work here. This is a less than problem, so I kind of knew that. And it's 0 is less than or equal to x, which is less than or equal to 9. Let's do this again. I have a GCF of 3, so I'll go ahead and take that out. This is a greater problem, so I should have an or at the end of the day. That'll be x minus 4, x plus 4. All right, so I have 4, and -4 is my 2 x-intercepts. I'm going to test 0, so that'd be 3 times -4 times 4. So that would be -48, which is not less than 0, not greater than 0. So that's a no in the middle and a check on the sides then. And that would tell me that either x is less than -4 or x is greater than +4. All right, last example. I have x plus 3 times x plus 3 is greater than or equal to 0. Therefore, I have x plus 3 squared is greater than or equal to 0. And that's telling me that my only x-intercept is at -3. So this is one of the special cases, okay? Because my situation here is like this. So it could be, right? Always true, right? Or it could never be true. So what I'm going to do is I can kind of logic this out, right? This has a positive a value, so it's concave up. And I want to know when it's greater than 0. So therefore, if it's concave up and I'm looking for when it's greater than 0 and it only has one x-intercept, then it must always be greater than 0. So that's how I know the solution is all real numbers. Or alternatively, I could test a number to the left of -3, like -4. -4 plus 3 is 1. -1, and square it, you get 1, so it works there. I would test -3 itself, which works, and then I would test like 0, and that still works, so it's all real numbers. Cool. Let's try the non-factorable ones. On these, you're just going to quadratic formula it, get your two x-intercepts, and then do the same thing. So here, like we have, remember, we're just going to quadratic formula it. So I'm going to just write the quadratic formula over here in red. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I would have negative 1 plus or minus the square root of 1 minus 4 times 2 times negative 8 all over 2 times 2. X would be negative 1 plus or minus the square root of 1 minus plus 32. Nope, 64 over 4. So X would be negative 1 plus or minus the square root of 65 over 4. And I can't simplify it more than that. So negative 1 minus the square root of 65 over 4. Negative 1 plus the square root of 65 over 4. All right. 0 is in between these two numbers because the square root of 65 is bigger than negative 1. So I'm just going to test 0. 0 plus 0 minus 8. Is that bigger than 0? It is not. So it does not work here. It does work over here. So x is less than negative 1 minus the square root of 65 over 4, or x is greater than negative 1 plus the square root of 65 over 4. Let's try that again. So x would equal positive 3 plus or minus the square root of 9 minus 4 times 1 times negative 8 all over 2 times 1. So x would equal 3 plus or minus the square root of 9 plus 32 over 2. So x would equal 3 plus or minus the square root of 41 over 2. So 3 minus root 41 over 2 and 3 plus root 41 over 2. 0 is in between there because the square root of 41 is bigger than 3. So I'd have 0 minus 0 minus 8 is less than or equal to 0. Well, that is true. So it's true in the middle. Therefore, it's not true on the ends. And therefore, and I should have known it's an and problem anyway. So therefore, it is negative 3 minus the square root of 41 over 2 is less than or equal to x, which is less than or equal to 3 plus the square root of 41 over 2. Okay. Here we're going to have two more special cases, and you'll see why. They're the same special case, but just two opposite ends of it. So here, x would equal negative 1 plus or minus the square root of 1 minus 4 times 2 times 5 all over 2 times 2. X would equal negative 1 plus or minus the square root of 1 minus 40 over 4. X would equal negative 1 plus or minus the square root of negative 39 over 4. So x would equal negative 1 plus or minus I root 39 over 4. Now, we should split that up ideally. But what we really need to worry about is that since it doesn't have x-intercepts, that means it's either entirely, we either have something that is entirely above the x-axis or entirely below the x-axis. I'm looking for something that is greater than 0, so I'm looking for something that is above the x-axis. And because I have a positive leading coefficient and it's concave up, this must be my situation. It must be above the x-axis. It must be concave up above the x-axis, and I want it to be greater than 0, so therefore this is all real numbers. Because this parabola exists above the x-axis. So that is greater than 0. To contrast, if I had x equals 1 plus or minus the square root of 1 minus 4 times 3 times 4 all over 2 times 3. So x would equal 1 plus or minus the square root of 1 minus 4 times 3 is 12, 48 over 6. So x would equal 1 plus or minus the square root of negative 47 over 6, and 1 plus or minus I root 47 over 6. And again, ideally we would split that, but we're not actually interested in the x-intercepts for the solution. We're actually just interested in them because, again, we either have something, because it doesn't have x-intercepts, it looks like this, or it looks like this. I want it to be less than 0, and it has a positive leading coefficient. Since it's a positive leading coefficient, this is my solution, but there is nothing down here. Therefore, this inequality has no solution. Thanks, guys. Have a good one.